Okay, guys, so today we are talking about solving quadratic equations using the square root property. So let's review. If we have a quadratic equation and it creates a parabola, how many times can the parabola cross your x-axis? Well, this first example right here, we have this parabola crossing our x-axis 2 times. So that means we have 2 real solutions. 2 x-intercepts means we have 2 real solutions. In our second example here, we have our parabola crossing or intersecting our x-axis only once. Our vertex is sitting on the x-axis. So one x-intercept means one real solution. And then this last example right here has our parabola never crossing our x-axis. That means we have 0 x-intercepts or no real solution. But if you don't have any real solutions, then remember from last semester, we can have imaginary solutions. So what kind of equations can you use the square root property to solve? Anytime you have an equation where you have an x term that is being squared and no other x value, what does that mean? Let's look at all of these examples really fast. They're on the back of your note sheet. Every single one of these examples has only one x value, and that x value is being squared. Ooh, something else. Let's remember something really fast. Let's use this blackboard. If I ask you what is 3 squared, probably shouldn't use the highlighter. Let's use the pen. 3 squared, that gives us positive 9. But what if I asked you for negative 3 squared? That also gives us positive 9. So you see here we had 2 separate values, 2 different numbers that would both give us a positive 9 when we square it. So if we give you the equation x squared equals 9, hopefully you could tell us that, hey, there are 2 different answers that we could square and give us the number 9, a positive 3 and a negative 3. So if we have here an x squared, to undo the squared, the inverse operation or the opposite operation would be to take the square root. So if I take the square root of the left side, I've got to take the square root of the right side of your equation. Okay, so we know square root and squared, those 2 functions undo each other. So we're just left with x. X equals, the square root of 9 is just 3. But as we just learned up here, as we just noticed, you have a positive 3 and a negative 3. So anytime you take the square root of both sides of an equation when solving for x, I immediately want you to write a plus or minus in front of whatever your square root is. Okay? All right, let's do some examples real fast. X squared minus 36. So I have one x value and it's being squared. Our job is to isolate this squared term first, this one right here. So how are we going to do that? Well, all we've got to do first is get rid of our minus 36, and the opposite operation or the inverse operation is plus 36 to both sides. And that gives us x squared equals 36. Okay, now I have my x squared term by itself. Our next step is just going to be undo squared. I don't want x squared, I just want x. So we've got to take the inverse operation or the opposite. We're going to take the square root. Our x squared, our square root and our squared functions undo each other so that all we're left with is x. So x equals, remember when you take the square root of both sides, immediately put your plus or minus, don't forget it. And the square root of 36, what value times itself makes 36? That's 6. So this right here is actually 2 answers. This is like saying x equals positive 6 and x equals negative 6. Those are 2 answers. We don't mind if you leave your solution like this, combined as one value. It looks like only one equation, or you can split them up like this. But both of those, you need to recognize those are 2 solutions. All right, so let's look at our second equation. Do we have only one x term? Yes. Is it being squared? Yes, it is, because this x value is inside this parentheses, and this entire set of parentheses is being squared. So we do have an x value that is being squared. We've got to isolate the squared term, the term that is being squared. So everything I highlighted in red right there. All right, what do we do first? We need to subtract our 7. Remember, we're doing PEMDAS in reverse. And that gives us 2 times x minus 1 in parentheses squared equals 105 minus 7 gives us 98. Right? It doesn't quite look like a minus 1. It's a little overlapping there. Sorry. Okay, so we still are trying to get our squared term by itself, this right here. So we need to get rid of the 2 out in front that we're multiplying by. And the opposite of multiply is divide. So we're going to divide this side by 2 and this side by 2. 2 divided by 2 reduces to 1. So we're left with x minus 1 quantity squared equals 98 divided by 2 gives us 49. Okay? Now, I still need to get to the x value, but I can't right now because it's stuck inside the parentheses. So I need to get rid of that squared value. How do we do that? We take the square root. Take the square root. Do not forget, anytime you take the square root of both sides of an equation, you're going to have a plus or minus as part of your answer. What is the square root of 49? 7. Okay? So we know our value is going to equal positive or negative 7. On the left side of our equation, square root and squared cancel each other out. They are inverses, so we have x minus 1. I'm almost finished, but I still don't have x by itself. So let's add 1 to both sides of our equation. And that gives us x equals. Now, I'm going to go ahead and write the number 1 first. What am I going to do with this 1? I'm going to both add and subtract the number 7. We're going to add and subtract the number 7. So this is, again, 2 solutions. Okay, because these are both number values, we can still combine them together. This is the same thing as saying x equals 1 plus 7 and x equals 1 minus 7. Well, what is 1 plus 7? That gives us 8. So we have x equals 8. And then 1 minus 7 gives us negative 6. So these are our solutions. Let's look at this equation. Do we have only one x value? Yes, it's in this parentheses right here. Is it being squared? Yes, it is, because the squared is on the outside of our parentheses. So we do have only one x value that is being squared. So let's isolate that. We need to reverse PEMDAS, so we're subtracting our 12 first. And that gives us 6 times x plus 2 in parentheses squared equals 78 minus 12 is 66. And then we need to divide both sides by 6 because remember, we are still trying to get our squared term by itself. Whatever is being squared, that's what we're trying to get by itself. So we needed to divide by our 6. 6 divided by 6 gives us just 1. So we have x plus 2 in parentheses squared equals 66 divided by 6 is 11. And we don't want x plus 2 squared. We've got to get rid of that squared. So let's take the square root of both sides. And anytime we take the square root of both sides, immediately you should go, oh, I'm going to have a plus and a minus for my answer right there. Okay, so the right side of our equation, I have the square root of 11. Well, way up here, the square root of 49 simplifies to 11, right? Because the square root of 49 was 7 times 7. But I can't break down 11, right? There are no factors of 11, just 11 times 1. So we have to leave this as the square root of 11. We can't simplify that anymore. And on the left side, square root and squared, they undo each other. So we're left with x plus 2. Oops. And because we're left with that, we don't actually need our parentheses anymore. That's all that's left over on the left side of our equation. But I still need to get x alone, and I've got that plus 2 in my way. So minus 2 from both sides of our equation. And we have x equals. Now this minus 2 and the square root of 11, we cannot combine those together because one's a square root and one isn't. So I'm just going to leave them separated. We have a minus 2 plus or minus the square root of 11. And it's usually easiest to always put the plus or minus symbol at the back of your answer. That's why we put our negative 2 in front and then plus or minus the square root of 11. So how many answers do we see here? This, you can leave your answer like this. That's just fine, but I need you to recognize that's two solutions. Your first solution is x equals -2 plus the square root of 11. And we also have x equals -2 minus the square root of 11. Either way, you can either write your answer condensed all together where both solutions are written together, or you can write them both separately. We're fine either way. In our last equation, do we have only one x value? Yes. Is it being squared? Yes. So this is my squared term that I am trying to isolate. So what do we do first? Let's subtract 70 from both sides of our equation. Remember, we're doing reverse PEMDAS to solve an equation always. So we have 4x squared equals, what is 6 minus 70? That gives us a -64. And then we need to divide both sides by 4 because remember, we are trying to get our squared term. Oops, I wanted to use blue for that one. Remember, we're trying to get our, red, squared term all by itself, right? So when we divide both sides by 4, divide both sides by 4, those reduce, and we're left with x squared equals -16. Okay, I don't want x squared, I only want x. So we're going to take the square root of the left side and the square root of the right side. And immediately I want you to think, oh, took the square root of both sides, I need to put plus or minus. Okay, so we know our solution is going to be a positive and a negative. Now, the square root of -16 is the same thing as saying the square root of -1 times 16. And hopefully you remember that when you take the square root of 16, it comes out as 4. But what was the square root of -1? Is there any value times itself that gives us a negative? Well, the answer is no. So the square root of -1 comes out as I, your imaginary number. So don't forget that anytime you take the square root of a negative, that -1 comes out as an I. And then there are no values left under our square root symbol to simplify. So it's just plus or minus 4i. And on the left side of our equation, square root and squared undo each other. So we're just left with x. And that right there is how many solutions? 2. X equals positive 4i, and we have x equals -4i. And again, you can write your solution like this, or you can write them separately. Either way is fine. And that's it.